Hello, I'm Grace Choi. Today's question is about the inverse trigonometric function. It is, personally speaking, much more interesting and exciting question. I guarantee. Oh, well, it looks so complicated, right? Square root, the pi, well, pi square, well, inverse. So we have to go on a diet. And then we have to make that question simpler one. Okay. So my first step is choose the simplest one. This. That is the simplest one. And then how about this? How about tangent inverse square root 2 over pi can be a? And then, original tangent function, you can say switch x and y. Tangent a is equal to square root 2 over pi. And then think about the range. A exists in the range of inverse trigonometric function, right? So, a minus pi over 2, right? That is a interval. Then, but this is a specific value using the tangent graph, very simply. Minus pi over 2, tangent graph is like this. And then square root 2 over pi, we can compare with the tangent pi over 4, because that is 1. The special angles, everybody knows that, right? So pi over 4 is here, the y value, tangent value is 1. Then compare this. That is square root 1.414, blah, blah, blah. Pi is 3 point, blah, blah, blah. So less than 1, for sure, less than 1. So A exists approximately here. A, right? Where is it? So we can say A is between 0 and pi over 4. Here is pi over 4. Okay. We can I just narrowed down the interval from here till here, the more concrete interval. Okay, what's the next step? So, well, anyways, the yellow one is A. Okay, what about the next? Oh, complex one. The green one. Next complex one. Oh, well. Now we have square root 2 is equal to pi tangent A. So I want to change that complicated one into more something related to A. Just my goal. So the green one, we can say cosine inverse. Instead of square root 2, here's the square root 2. Well, I just substitute pi over tangent A. Challenge, just challenge. And then denominator is this. As you see, square root 2, instead of 2, just a perfect square. Pi square tangent A square. Good. Pi square tangent A square plus pi square. Yeah. We can simplify the denominator for sure, because factoring is possible. Pi square, right? So this part denominator, pi square bracket 1 plus tangent A square. Oh, 1 plus tangent A square, that is secant A square, remember? Secant A square. So secant A square. And then square root. Ooh, much simpler. Huh? Then pi secant A absolute, we can say. So denominator, I like this, pi absolute secant A absolute. Because we don't know the sign of secant A. Huh? So now, is it positive or negative? Ah, yeah, we have A interval, A between 0 and pi over 4. Secant A also, A is acute, for sure, acute angle. So secant is 1 over cosine. So cosine acute angle is always positive. Therefore, yeah, we can erase absolute. Phew. Pi is secant. Cool. Oh, simplify like this. Instead of tangent, we can say sine over cosine. Instead of secant, we can say 1 over cosine. Okay, good, very good. Simplify more. So therefore, just this complicated part is just simply speaking, just sine. Thank you, thank you. Sine now. Sine A. Good. But no, not sine inverse, not cosine inverse. How about this? Instead of sine, cosine pi over 2 minus A. Oh, no problem at all. Okay. And then what is next step? Here is original function, and then cosine inverse. Is it pi over 2 minus A? We have to check. We have to check because cosine inverse, cosine x is now x. But there is a specific condition for this conclusion. X should be between 0 and pi. Okay. Let's check. Now A is 0 and between 0 and pi over 4. Pi minus 2 minus that value. Okay. Minus A, then minus pi over 4 and 0, then plus pi over 2. So pi over 4, pi over 2 minus A, pi over 2. Well. Pi over 2 minus A can exist here. For sure. Therefore, we can guarantee the value is just as it is, no change. Just pi over 2 minus A, that's it. Oh, okay. So far, so good. I'm very satisfied. What about you? And the purple one. Using this tangent blah blah. Using square root 2 is equal to pi times tangent A. Use this. Okay, this part. Numerator first. Numerator 2 times, instead of square root 2, just pi tangent A times pi over 2 plus pi square. 2 is here. So pi square tangent A square factoring plus 1. Ooh, pi square. Good, very good. And then tangent A square plus 1 is secant A square. Very cool. The numerator, 2 times sine over cosine, denominator, secant 1 over cosine square, and then simplify more, cosine. Therefore, 2 sine A cosine A Aha, that is sine double angle identity, right? Sine 2a. Very cool, very cool. But not the end. Huh? We need to check. So anyways, just this part, this complicated part is into simply sine 2a. Huh? Sine 2a. Okay. Sine 2a, sine 2a. So the purple one is now sine inverse sine 2a. Is it 2a or not? Not sure. Not sure. A interval is this. Huh? A between 0 and the pi over 4. And then sine inverse sine x can be x. There is also specific condition about x, you know, to be this, to be this. X should be between minus pi over 2, pi over 2, inclusive each. Okay, let me check. The A interval is this, times 2, okay, times 2, 0, and the pi over 2. Oh, this exists in here. For sure. Oh, thus sine inverse sine 2a can be 2a. Okay, don't panic, don't panic. All right, in conclusion, now pi 3 over 2 here, 3 over 2, then the green part, finally pi over 2 minus a, and then plus 1 over 4. Then purple one, just 2a. Then the yellow one, just a. This is conclusion. And then distribute. 3 pi over 4 minus 3 over 2a plus 1/2 a plus a. Amazing. Cancel out, erased permanently. Bye-bye. So final answer 3 pi over 4. Final answer 3 pi over 4. 3 pi over 4, but this is a JEE advanced exam. So your answer 3 pi over 4 is impossible. Just round off 3 pi over 4 to 2 decimal places. So approximately 3 times 3.14 over 4, 3.14 times 3, 2, 4, 9, divided by 4, 2, 8, 4, and then 3, like this, okay? Approximately 2.36. That's the answer. Personally, very hard. And but you can overcome any obstacles you face. Cheer up.